Hey, problem solvers, welcome to math. We are going to take another look at factors, just like we did the other day, and then we're going to go a step further with it. But before I tell you what we're going to do, let me share my screen, and we are going to look at these two numbers. We've got 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So first, let's look at 5. How many factors of 5 can we find? How many different rectangles can we make out of 5 squares? Well, first we can already see, that we can make this square that's 1 by 5, right? 1 square by 5 squares. Okay, cool. Is there any other way that we can arrange these squares to make a good rectangle? What if we do this? Let's see. Oh, no, see, there's one left over. It doesn't work. So 1 and 5 are the only factors of 5. And remember, we list them in order. 1 and 5. Now let's look at 6. I know some of you can probably do this in your head, but just to check our work, let's go through it. So we know we can make a rectangle that looks just like this. 1, not by 56, 1 by 6. 1, 2, 3, 4, 5, 6 by 1. What other rectangles can we make? What if we bring these over here? One, 2, 3 by 2. Right? And I know we can also make this rectangle, which is 3 by 2, but it's kind of the same, which is 2 by 3 rather, but it's kind of the same thing, right? So if we list out our factors of 6, we've got 1, 2, 3, and 6. Now, there is a name for the difference between these two numbers. 1 and 5 are the only factors of 5, which makes it a prime number. Prime numbers are numbers that only have 2 factors. Just like 5. The only 2 factors are 1 and 5. So then what do we call 6? A composite number. A composite number is a number that has more than 1 factor. So 6 has 4 factors. It is a composite number. 5 has 2 factors. It is a prime number. I'm going to be asking you guys in the next couple of weeks to identify whether certain numbers are prime or composite. So we need to know the difference. I'm going to pause for a minute to share my iPad screen, and we can take a look at a few more numbers and determine whether they are prime or composite. I will be right back. All right, let's take a look. What if I give you the number 7? Is 7 prime or composite? Let's list all the factors. Remember, we can do it this way. 1 times what equals 7? 7. 2 times what equals 7? Nothing, so we can erase that. 3 times what equals 7? Nothing. What else? 4 times what equals 7? Nothing. You can't multiply 4 by anything to get 7, right? 4 times 2 is 8. What about 5? What can you multiply 5 by to get 7? Nothing. And without me even writing it, what about 6? Nothing. You can't multiply 6 by anything and get 7. So our factors for 7 are 1 and 7. Is it prime or composite? It is prime. Woo! All right, let's take a look at another one, huh? What about, scribble, 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 scribble. What about 10? Is that prime or composite? Now you can go through what I just did and multiply every number, but I'm not even asking you to list the factors right now. I'm just asking you to tell me whether it's prime or composite. And pulling off my prior knowledge of multiplication, I know fully well that 5 times 2 equals 10. So without even having to go through the process of making sure I have every single factor, I know that 5, 2, 1, and 10 are factors. And so I know that this is composite. It has more than 2 factors. It is composite. Should we look at another one? 11. Prime or composite? Off the top of my head, I can't think of anything other than 1 times 11. 2 times something? No. 3 times something equals 11? Nope. Can we do 4 times something and get 11? Nope. 5? 6? 7? 8? 9 times something. Can we get 11? Nope. What about 10? Nope. Our only factors of 11 are 1 and 11, which makes it a prime number. I was not looking at the screen when I did that. That is not my best handwriting. A prime number. Very good. Shall we look at one more just to get enough practice in? What about 12? Prime or composite? Well, of course, I know that 1 times 12 equals 12. What about 2? Yeah, right there, you can stop. I know right there it is a composite number. Now, if the question in front of you asks you to list all factors and then tell if it is prime or composite, then maybe I'm not done. Maybe I have to look further and check 3. But if all I'm asking for is whether a number is prime or composite, you just need to find that one extra set. So 12 has more than 2 factors. It is a composite number. I know I said that was the last one, but I've got a little bit of a trick question for you. What about the number 1? Is the number 1 prime or composite? Think about it. I gotta admit, it's a bit of a trick question. 1 is neither prime, nope, or a composite. Nope. The reason is that 1 only has 1 factor. Because the only thing you can multiply to get 1 is 1 times 1. And remember, a prime number has 2 factors. A composite number has more than 2 factors. 1 has 1 factor, so it's neither. Another quick trick question. What about 0? Is 0 prime or composite? It is another trick. It is neither. And the reason is that 0 actually has an infinite amount of factors, because you can times anything by 0 and get 0, right? even like 2,587 times 0 is 0. It is an infinite amount of factors. It is neither prime nor composite. And just to get back in the swing of things real quick, let's do one more. It's a bit of a tricky one. What about 19? I'm not going to tell you that answer. I want you to do this by yourself. Bring the answer to Zoom. Is 19 prime or composite? Question mark. Bring your answer to Zoom. Make sure to be prepared to explain your thinking, and I will see you there.